All right, for geometry today, we have 8-7, the coordinate geometry of circles. All right, so our objectives are to write the standard form equation of a circle using its center, okay, and either its radius or a point on the circle. So doing both of those. And to convert equations of circles to standard form. Then, it says, and state the circle's center and radius. So we just have the one sheet, the one side today, but there's a lot of good stuff in there. All right, so first of all, let's look at standard form. Okay, so the standard form equation of a circle is here. It's the quantity x minus h squared plus the quantity y minus k squared equals r squared. Okay, so your circle is centered at h comma k. So that's the center, and it has the radius r. Okay, so again, here is your h, and here is your k. Notice the trippy part is going to be that these are, in the formula, they're subtracted. So if you have the quantity x minus 2 squared plus the quantity y plus 4 squared equals r squared. Okay, in this case, your h is equal to 2 because they both have the subtraction in front of them. Your k here is not equal to a positive 4, it's a negative 4, right? Because the formula has a minus, but the example that we have has a plus. So that means this has to be y minus negative 4 to become y plus 4 later. So that part you have to memorize that formula so you can use that to help you. Okay, then equations written in standard form can be graphed using the circle's center and radius. It's actually really super cool that we can do this. So example 1 says write the equation of each circle. So we're going to substitute the coordinates and the radius into the standard form equation and simplify. It's so simple here. We have the circle centered, so we have the center at 0, 4. Okay, remember that this is the same as your h and your k value with the radius of 3. Okay, so our r equals 3. We're going to plug them right into the formula. Okay, that formula is x minus h squared plus y minus k squared equals r squared. Just copied it right down. Let's plug our values in though. X minus our h. The other thing you can remember is that the x and the h are going to go together because they're both the, like, right, when we look at this coordinate 0, 4, it's the same as an xy coordinate. So your h goes with the x value here, and your k goes with your y value because it's in the same place as the y. Okay. So we're going to have x minus 0. Okay, let me go back. Squared plus y minus, your k here is 4, squared equals our radius, 3 squared. Okay, and then we can take that one teeny tiny step forward and square our radius. So we're going to have x minus 0 squared plus the quantity y minus 4 squared equals 9. All we did was simplify the 3 squared, okay, to get it in that form. Which, yes, we should do, because most of the time you're not going to get r squared. You're going to get a numerical value. All right, now we want to write the equation of this circle, but it's graphed. So we need the information of, hey, where's the center and how long is the radius? That's the info we know, or we need. Okay, so to find our center, we start at 0, we go -2, +1. And the radius, how far is it from the center to the edge? What's that distance? It's a distance of 2. So my radius is 2. All right, now we put those values into our formula. Okay, so we're going to have x minus, what's my x value up here, or my h value? Oh, it's -2. So x minus -2 plus y minus k. What's my k value? Good. It's 1. All right, let me cover that with purple. Equals my radius squared. My radius is 2, so this is going to be 2 squared. Sorry, I'm trying to color code so you guys can very clearly see the numbers we put in. All right, now let's simplify. X minus -2 is the quantity x plus 2, plus, we can't do any simplifying here, so the quantity y minus 1. These should both be squared. I don't know where my brain is, so let's sneak that in. You guys probably already caught that. Equals, what's 2 squared? Perfect, 4. So there you have it. There is the standard form equation of your circle. Okay, so far so good, I hope. Let's go on down to example 2. It says write the equation of a circle centered at C, -2, 9, and passing through P, 3, -4. All right, so this one is a little bit different because it is passing through a point, which means we do not have the radius. Okay, however, we can use the distance formula to determine the circle's radius. Nice. Okay, so we have d because it's the distance formula. You recall back. So distance equals the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Well, we're just going to call that, rename it r, okay, because that's our r value, our radius. And we're still going to do x2 minus x1 if you remember, right? Because the circle's center is at h comma k, which is the same thing as an x comma y value. So we're still doing the same idea of x2 minus x1. We're just calling them the x value from here and the h value from the center. And then the y value from the point and the y value or the k value from the center. It's the same thing. We're just giving them different names. Okay. All right, so let's start with this distance formula, or the radius formula. Okay, so we're going to do the radius equals the square root of our x value. Our x value is 3, minus our h value, which is -2. Okay, and that quantity is squared. Let me change up colors here. Then we're going to do plus, let's get to our y. So we need the y value, which is -4, minus our k value, which is 9. And that's squared. All right, let me extend out my radical because it goes that whole distance there. Okay, so there's our formula. We just plugged in the x and the y and the h and the k so we could solve for our radius. This is the variable we want. All right, so let's do some simplifying. 3 minus -2 is the same thing as 3 plus 2. So this is going to be 5 squared plus -4 minus 9 is -13 squared. Got my radical sign a little long there. All right, so this equals the square root of 25 plus -13 squared is 169, which, if we add those together, is the square root of 194. So our radius equals the square root of 194. All right, and I'm fine with that. We don't have to simplify it any further at this point. It is okay. All right, so then it says, though, we're not done. Write the equation of the circle centered at this point. We did not write the equation of the circle. So this really, I typically circle those kind of intermediate answers. So this one should have been circled instead of squared. It's a minor detail. It's just what I typically do, so I don't forget that there's more to do. All right, so now that we know our radius, we need to put it in, all the stuff into our equation. All right, so let's change up. And we're going to go back to that equation. If you remember, it's the quantity x minus h squared plus the quantity y minus k squared equals our radius squared. Okay. So we don't have to put in our x values, okay, because those, we're getting our equation in standard form. We're going to leave the x and the y, just like we did above. We're just going to put in our h and our k values. So we have x minus, our h is that -2 again, so I'm going to put -2 squared plus the quantity y minus k is 9 squared equals our radius squared. Well, our radius is the square root of 194. So this equals the square root of 194 squared. And you'll see why I said you didn't have to do any more work to that. Time to simplify. X minus -2 is the same thing as x plus 2 squared. Y minus 9, we cannot simplify, so we're going to leave it as y minus 9 squared equals, now here comes the fun part. The square root of 194 squared is simply 194. There was no reason to simplify this radius over here when we got this, because we're just going to turn around and square it over here. So we could save ourselves a little work. So this is our final answer. This is the equation of our circle in standard form. Okay. We always have the x and the y in there, and the other values, the h, the k, and the radius are solved for in standard form. Now in example 3, we get to sketch a graph of the equations. So that's kind of fun. All right, in order to sketch them, we need to compare each equation to the standard form to determine the coordinates of the circle's center and its radius. And then we sketch it. All right, so let's look at the first one. We need the center. Okay, so my h value, it says +1, so it's going to be a -1, comma. My k value, it's -5, so this is going to be 5. Because remember, it's the opposite of what's given. So my center is at -1, 5. My radius, okay, is what we've got to solve for next. Remember, this value is equal to your r squared. So the radius is the square root of 4, which is 2. So we're going to go to -1 and then go up 5. 1, 2, 3, 4, 5. That's my radius. Or that's my center, pardon me. My radius is 2, so I'm going to go over 2, put a point. I'm going to go down 2, put a point. I'm going to go left 2, and I'm going to go right 2 to get my radius in all 4 directions. And then I'm going to make a circle around it. Not the best looking circle, but that's it. That's how you graph it. Okay, so let's do the next one. We need the center and the radius. Okay, here we have an x squared. So what's our h value? Yeah, it's just 0, right? If there's nothing there. And how about our y value? Or sorry, our k value, because it's y equals y minus 1. Good, our k value is 1 here. The radius, okay, we've got 16, so we have to take the square root of 16. Perfect, that is 4. So our radius is 4. And let's graph it. So 0, 1 is our center. And from there, we're going to go out 4 places. Right, left, up, and down. 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It's really hard to see these lines up here, so if they don't look quite right, 1, 2, 3, 4. I apologize. All right, so it's a little lopsided circle. I'm not very good at drawing circles on the board. But there it is. Okay, on to our last one. So we need the center and the radius. Okay, so my center is at, good, 3, what's my K? Awesome, -4. And how about this radius? Got to take the square root of 9/4. Can you do it? Okay, so the square root, we would do the square root of 9 over the square root of 4. So this is equal to 3/2. So 3/2. All right, so I also get that in graphing fractions in this case for a length is harder. So we can make that the equivalent decimal, 1.5. That works for me. So we're going to go over, we're going to graph our center. So 3, -4, 1, 2, 3, 4. Okay, and then from there, we need to go left, right, up, and down, 1.5. So 1.5, 1.5, 1.5, 1.5. Okay, and we make our circle. It's a teeny tiny circle. Okay, and that's it for today, right? For the coordinate geometry of your circles. So you have page 389, numbers 1 through 21 to do.